Hello, hello! Here is the video on writing equations for piecewise functions. So you are presented with a graph of a piecewise function. So we can see we have three pieces on our graph, and what we want to do is we want to use that information to be able to go backwards to write the equation. So the first thing I want to do is I actually want to find my boundaries between each one of these pieces. So right here, I can see there's a boundary at the that's the y-axis, at the y-axis, and a boundary at x equals 2. So those boundaries are going to help us create our restrictions on our domains after we write our equations. So looking at these pieces, I can see this first piece all the way on the left is a quadratic function because I recognize it as a U-shaped graph. I can also see that it is opening down, and it also has been shifted 1 unit to the left. I can also double check to see if there was any sort of stretch or compression from the original parent function of y equals x squared. But if I look at my points for this portion of my quadratic function, I can see that those points are still spaced out 1 unit horizontally and vertically, so there is no stretch or compression. So all I really need to take into account is that it is opening upside down and it moved to the left 1 from our original position of our parent graph of y equals x squared. So taking that into account, I can go ahead and write the equation. I need the negative because my parabola is opening down, and since it is opening to the left, I'm going to put x plus 1, not opening to the left. Since it moved to the left 1 unit, I'm going to put x plus 1 in my parentheses with the square on the outside. So this goes back to our parent functions and the transformations. So that is making the adjustments with a, our function, x plus or minus h, plus or minus k, where a signifies if there's a stretch or compression, plus or minus h tells us if we move to the left or to the right from our parent function, and plus or minus k tells us if we moved up or down from our original parent function. So this portion of the graph is for all of the values that are less than 0 on my x's. So that's over here. So everything that's less than 0. And I can see that it ends with an open circle, which means I am going to have just a less than. So I'm going to write x is less than 0 for that restriction. If I had a closed circle, I would have it be less than or equal to. Okay, so the middle part of my graph is just a horizontal line at 3. So to write that as an equation, that's just going to be y equals 3. And this part, this interval, goes from 0 to 2. So I can go ahead and write that as an inequality. So 0 is less than or equal to, because of the closed circles. X is less than or equal to, again, because it's closed, at 2. So there's my middle graph. My graph that is furthest to the right, I can see it is an absolute value function. I can also see that it has been an absolute value function that has shifted to the right 3. I can check to see if there's any sort of stretch or compression. These points are 1 unit apart, so there is no stretch or compression, so it's just shifted to the right 3 units. So I'm going to go ahead and write that as absolute value of x minus 3. And then for my restriction, it was for everything that was bigger than 2 for my x's. So I'm going to write this as x is greater than 2, and I don't have the or equal to because looking at this part of my graph, it is an open circle. We can also write our restrictions on the domain as intervals. So x is less than 0 can be written as negative infinity up to 0. For my middle interval, 0 to 2 with brackets, since both of those are included. And for my last interval, that is 2 to infinity. So there is your piecewise equation for number 1. All right, number 2. I'm going to do the same thing. I'm going to go ahead and start by finding my walls between my pieces, because that's going to help me figure out the different restrictions that I need. Okay, so I can see this first graph over here is a straight line, so it's a linear function. So when I'm writing a linear function, I'm always going to write it in slope-intercept form, y equals mx plus b. So I need to figure out what my slope is and what my y-intercept is. So for my slope, I'm going to go ahead and find some points that are nicely plotted on the grid, and then I just need to figure out my rise over run. So to get from this first point to the second point, I'm going down 3 over 1, so that means my slope is -3. To find my y-intercept, I'm actually going to continue this graph until I hit my y-axis. So I'm going to continue going down 3 over 1, down 3 over 1, and I can see I'm going to hit my y-axis at -1, so that means b is -1. I'm going to go ahead and erase some things, just so we don't have overlapping pieces as I continue to explain stuff. So now that I have my m and my b, I can go ahead and write my equation. It is -3x minus 1. And this is for all of my values that start at -1 for my x, and everything to the left of that. And I can also see, actually I need to erase so I can actually see, there we go. I can see that that is a closed circle, so that means I'm going to have that or equal to. So I'm going to write this as x is less than or equal to -1, and that gives me that first portion of my piecewise function. For the middle piece, right here, I can recognize that graph as a cubic, and I can also see for my cubic it hasn't been shifted at all. It's starting at 0, 0, going to 1, 1, as well as -1, 1, so there's no stretch or shrink at all either. So this is just going to be x cubed, and for my restriction it is going from -1 up to 2. Double checking for open or closed circles for my inequalities. It is open at -1, so I'm going to do -1 is less than x, and it is closed at 2, so less than or equal to 2 for that other piece of my restriction. And last but not least, I've got this graph over here. So that graph I can recognize as a quadratic function since it is a U-shaped graph. I can also see that it has been shifted to the right 3 units, and it hasn't been shifted up or down at all, but let's double check for stretches or compressions. So I'm starting at my vertex, finding my next nice point, and I can see that it is stretched vertically 2 units. So I'm going to do a vertical stretch of 2. So to write that as an equation, I'm going to go ahead and put my 2 in the front. It has shifted to the right, so that's x minus 3 squared, and it hasn't moved up or down at all. So there's your equation. And this is for all of my values of x that are greater than 2. So x is greater than 2. And of course, we can write these as intervals. So my first interval would go from -infinity up to -1. Middle interval is -1 to 2. And third interval is for everything that is greater than 2. So 2 to infinity. All right, last one. Going to set up my boundaries. I have one at 3, and I also have one at 0. I'm going to go ahead and find my equations. I can see that this piece right here is linear. So again, I want to identify my slope and my y-intercept. I can see that for my slope, I'm going up 1 over 1, so that's nice. I'm going to go ahead and continue to see where it's going to hit my y-axis, and it's going to hit it at 4. So my y-intercept is 4. I'm going to go ahead and erase these dotted lines so we don't get confused as I do that middle graph. So this equation is just going to be x plus 4. And that is for all of my values of x that are less than negative 3. So x is less than negative 3, not or equal to, because at the end of that graph it is an open circle. All right, middle piece. Middle piece I can see is a quadratic. I can also see that it has shifted to the left 2 from the original parent function and up 1. Checking for a stretch or compression. Those are 1 unit apart, so there's no stretch or compression at all. So it's just a left 2 and up 1. So I'm going to write this as x plus 2 squared plus 1. And those are for the values in between negative 3 and 0, inclusive at the negative 3. So negative 3 is less than or equal to x is less than or equal to 0, because I can also see I have a closed circle at the end of that parabola. All right, cool. Last one. I can see that this is an absolute value function. It has been reflected because it's opening down. I can also see, to get to here, I have moved to the right 3 and up 4. Up 4. And let's check for that stretch or compression at all. So looking at these points, I can see that it is stretched vertically 2 units. So that is going to be a vertical stretch of 2. Okay, so writing our equation, since it's opening down, I'm going to make my 2 negative. And then inside my absolute value, it moved to the right 3, so x minus 3. And also moved up 4, so plus 4. And this is for all the values of x that are greater than 0. All right. And last but not least, we can write our restrictions as intervals. So my first interval goes from negative infinity to negative 3. Middle interval goes from negative 3 to 0, both inclusive. And last interval, 0 to infinity. All right, so that finishes up our video on writing equations for piecewise functions.